Hello everyone, welcome back. In today's video, we are going to build a clean system health checker using Python, where it shows live CPU usage or RAM usage and disk usage with progress bar. It also shows warning message and sends a desktop notification if CPU usage goes too high using plier. So let's get started to build this amazing cool Python project. So first we need to importing some libraries. So we can import here. First one we need psutil. psutil is a library which lets our program read system information like CPU, memory, and disk usage. And again, after this, we need to import Tkinter, and we can use as TK. It is a graphical user interface toolkit, and let's us call it TK for shorter code. So we can use Tkinter as TK. After that, we need to import from Tkinter. We need to import TTK. Okay, this provides theme widgets that look more modern than base Tkinter widgets. We will use it for progress bar. After that, we need from Flyer, we can import notification. It sends our desktop notification using Flyer. After that, we need to define a class, so we can create class here class, and we can use system health checker. Then we need to create a constructor, so we can create function. We can call init, and here we can pass self and root. Basically, this is a constructor. Python call this function automatically when we create this system health checker object, and we pass this root, which is the main Tkinter window. Then we can use self dot root. Okay. This stores the root window on the instance so that other method can access it. For that, we need to create title of the window, so we can use root dot title, and we can simply name them uh, system health checker. Using this self.row dot title, we can show text on the window title bar. Here I can show here. This is system health checker. This is our title of the project. For that we need to set the window size, so we can use uh, self.root, and we can use here geometry, and we can simply use 625 pixel into 625 pixel. You can choose according to you what size you want on your project of the window. And then lastly, we can use self dot root dot resizable. We can give false and false. Basically, it's disabled resizing the window horizontally and vertically, so layout stay consistent on the project. Now we can use self dot root dot configure and give background color is equal to. You can choose own background color, so you can customize according to you. Here I can choose background color is a dark blue. Okay, after that we need to create app title label. First I can show you. Okay, after this we need to create this system health monitor, so we can use. So after this we need to create a title, so we can use here tk dot title, tk dot label we can use here. Then we can use root, and we can name system health monitor. Now after this we need to create a font and size and bold, so we can use here font poppins 18 and bold, and background color is again dark blue. And this is our text color, foreground T label color. You can choose according to your preference. You can choose any color. After that, we need to use your pack, and paddy is equal to, I can give 25. This pack is a geometry manager. Place it on the window and adds vertical spacing below the label. After that, we need to create CPU usage with progress bar. So let's code for it. So first here we can use comment. Here we can create title, and then we can create for CPU usage. So again we can simply copy it and paste here. And now we can change a little bit here. CPU usage, CPU usage in percentage, and here we can simply change. We can add self dot CPU label is equal to, basically this self dot CPU label creates a label to show CPU percentage text initially set to this percentage, and we simply change here 14, and here we can choose foreground color is equal to white. Here we can use self dot CPU label. So we can, here we can paste it. It's labeled to the window with small vertical spacing, and we can again use, now for progress bar we can again use self dot CPU label, and here we can use bar, and we can use your t2k dot progress bar. We can use root, and we can length, we can give length to the progress bar is equal to 350, and the mode is equal to use, we can here determinate. Okay, this creates a determinate progress bar. We control exact value, that is 350 pixel wide, and after that we can copy it, and we can again use path.paddy, adds progress bar to layout. After that we need to create this one RAM usage and this progress bar. Now after this we need to create RAM usage, so we can simply copy it and paste here. Okay, I need to copy this from here, because we need to change only name as RAM usage, because here you can see we can created this one, so this one is look like similar, so we can copy it. So we need to change only here RAM label, and here we can change RAM usage, and here this I need same, and here we can change RAM name, and here also we can change RAM, and here also we can change RAM. Okay, we are now successfully built this RAM usage section. Now again we can copy it for disk usage and only change name. I hope you understand this. For disk we need here simply for uh, disk usage, and simply here copy it, and again here we can change this variable uh, disk, and here we can change name text is equal to disk usage, and here again we can change variable disk. Now we can successfully build also disk the usage. So all three options are we need to successfully build this. After this, okay, here we cannot use 15, we can use 5. After that, we need to create this warning pop-up message. So first we need to create status label uh, is equal to a status label display here is system running smoothly if CPU usage below the high usage, and it shows warning about this message if CPU was high usage. So initially we need to create, so here we need to create a status label, So we can again use self dot status. We can use tk dot label. We can use root and we can name text here, here, here. Initially here text starts with empty, and we can give, and again we can use here font, so we can copy it simply and paste here font is equal to Poppins, and here we can give 13 and bold, and here we can change color into uh, we can use hash. Here we can use choose this color, and simply we can in the last we need to use self status label, and you can use again pack paddy is equal to, here we can use 10. Okay, this message this helps to display a small message like system running smoothly or warning about high CPU usage. For after that we need to create alert state and starting updates, so we can use self dot alert zone, and here we can choose false. Okay, this returns alert message pop-up where when CPU remains high, and then restart later, restart sorry reset later. Then after that we need to create uh, update start, and we can update status. Using this we can immediately call the function that fetches and update the system stats. Now after this we need to defining the update function, so we can use def update stats, and we can pass self. Okay, basically this function will read CPU, RAM and disk usage, update the level and progress bar, changes colors depending on load, and show notification if needed, and schedule itself to run again. After that we need to read system, so we can first we need to read the CPU, so we can use CPU usage, and we can use psutil dot CPU percent, and we can simply use interval 1. I previously said Sutil. Sutil is a cross-platform library for retrieving information on running process and system utilization, like CPU, memory, disk network, or sensor in Python. So basically, it means it is used to read system information like CPU, memory, and disk usage. So we can use for CPU, you can use cpu.percent. After this, we need to read RAM usage. So we can use RAM usage, and we can simply use sutil psutil dot virtual memory dot percent. Okay, this helps to return current RAM usage as a percent 0 to 100. And after that we need to read disk usage, so we can again use disk usage, and again you can use psutil, and we can use your disk usage, and we need in percent. Basically this return disk usage percentage of the root directory uh, on window if desired. After that we need to update label text, so we can here we can update label text to show current numeric percentage, so we can use self dot cpu label, and we can use config, and using f string the CPU usage, and we can simply pass your CPU usage. This will print CPU percentage. So here I forget, we can use text. Okay. Basically this property helps to show current numeric percentage of CPU usage. So now same as RAM, we can use same as RAM usage. So again we can use self, and we can use ram dot label, and we can configure it, and simply use text using f string. You can call RAM usage and pass RAM usage. Basically, this also print numeric percentage of the RAM. Then again, we can use for self. So we can use here disk label, and we can again configure it into text using a string to display disk usage. Simply pass disk usage in percentage. Now after that we need to set progress bar values. This this one progress bar values. So for progress bar values again we can use self, we can use CPU bar, and we can simply pass here value and simply CPU usage. This display exact value of CPU bar. Again we can here we can use RAM bar, and here we can use disk bar, and here again we can change as disk. Now after that we need to create a function to decide color. So color based usage, so we can again use to create function or get color, and simply pass here value, this one, and if value less than is equal to 50, then we can simply return color. If value is less than 50, then return color is green. Alif, we can use alif value. If less than 80, then simply return color. Okay. If value less than is equal to 80, then return this is yellow color, and else we can choose color. So we can again use return and choose color. Okay, uh, this green remains safe, and if color becomes yellow, then it's become moderate, and if get color becomes red, then CPU is on at high risk. So after that we need to determine colors for each matrices. So we can use simply color for CPU, and we can use get color, and simply pass here CPU usage. So we can, and CPU, and then you can hear RAM. Here we can use disk, and here we can use RAM. Okay, this will be error, so we can remove this. After that we need mm, what will be perfectly fine. After this we need to add notification logic. So so notification we need to use if CPU alert. We can use CPU usage greater than is equal to 80, and you can use not, and then you can use self dot alert shown. Then we can use notification, then notify, then we can use title here. Then we can use high CPU usage and zone alert, and you can use message using f string. We can show CPU usage is at, we can pass here CPU usage in percentage, and after this we can system We can print system may slow down, and we can use timeout. System slow down, timeout is equal to 5. After this, we need to use self dot status label, and we can configure it with text warning, high CPU usage, and use foreground and give color. And after that, we need to call self dot alert zone is equal to true, and we can use elif if CPU usage less than is equal to 80, then self dot alert is equal to false, and simply call self dot status label and use config text system running and write system running smoothly. And after this, we need to add foreground. Basically, elif if CPU drops at below 80%, then this message change the label to a positive message. Okay, here why this happens, I don't know, so remove this. And using notification dot notify changes the uses plier to send desktop notification. And if CPU is greater than then if CPU usage greater than 80, then this high CPU usage alert will be shown. So our alert will be completed. Now go for next, schedule the next update. So we can use self dot root dot after, and we can write 5000 millisecond, and we can pass self dot update status. This line update the status in every 5 seconds. So using this, this creates a loop where function fetches the data. After that, we need to run the app. So we can simply write, okay, this line works to ensure this code runs only when the file is executed directly. So we can use root. After this, you can tk dot, then we can create tk dot tk. This is basically means it starts to create the main Tinker window object. And after that, we need to simply use f dot system health checker and simply pass your root. And simply in the last, we can use main loop. Okay, this constructor using immediately call update status to start updates, and root dot main loop starts Tinker event loop. This line ensures that it keeps the window open and responsive and listening for events like uh, or redraw. And when you close the window main loop, its end and the program exits. So code is now completed, and now we need to run this project. Okay, so first you need to import the psutil library, install pip psutil library and plier library, and after that we again run this project. So our project is running perfectly, you can see now. So that's it. We just build our cool system health monitor in Python that track CPU usage, RAM usage, disk usage, and event alert when system load get high. So thanks for watching.